Compañeros, welcome to another edition of the SQL Data Partners Podcast. This is episode 208, and we are very fortunate to have longtime listener, very long-time listener, and caller. That's right. So she has the distinction of being the only person in SQL Data Partners Podcast history to use the call-in feature, right? Leave us a recording. So Mala Mahadevan is with us on the program. Welcome, Mala.
Thank you. Pleasure to be here.
So we're going to be talking about SQL Graph and SQL Graph database and graph types. But as always, we have a couple of other things that we want to get to first. One, we want to give a couple of shout outs to some other folks who are listening. We've got Carlos Garcia, Dan Watson. Now, I'm going to say that as Shingal?
There's no H, Singhal.
Singhal, thank you. Singhal. Mike Safran and M. Pavan Kumar Reddy.
So I have two shout outs from my side too.
Here we go.
Okay, I want to give a shout out to my colleague Ephraim Sharon, who is one of the few brilliant database people I've had the fortune of working with. Really smart person, and has been incredibly supportive to me in my steep learning curve as a DBA to a DBE. And also my amazing boss, Marshall Smith, who I think, everybody deserves a boss like him. And if you ever happen to do a show where you want to interview how a complete non-database person can manage a seriously smart group of database people, you should talk to him, because he does an excellent job with that. So those are the two people I want to call out.
Very good. Thank you. And this is what I love about having you on, Mala, right? So you have come in and you gave us some shout outs, right? Which is very nice. I feel like I'm, go for it.
I said two more than I've ever done.
Yeah. I feel like I'm trying to suck these shout outs out of these guys, and they don't want to give them. So thank you for doing that.
From a turnip.
We're just ingrates.
Yeah. So we are interested. We are always interested. So compañeros, right? So we finally were able to get Mala on. If you have something you want to talk about on the podcast, let us know. We're very interested in having you. We can make time, right? Come on, and we'll talk about something. Okay, so our show notes today for today is going to be on SQLDataPartners.com/graphdata or at SQLDataPartners.com/208. And before the show, we were recording, or we were chatting, and Mala reminded me that we have t-shirts available, and then she chastised me because we don't have any female shirts available. And this is something that we've actually done. So on SQL Trail, we've always made female sizes available. But when we originally did these podcast shirts, we didn't do female for whatever reason. However, I will change my wicked ways and I will make some available. And so we'll make the commitment. So if you head to, let's see, on the episode, I think at SQLDataPartners.com/t-shirt, singular, it'll point you to Etsy. And by the time this episode airs, we will ensure that there are female sizes and cuts of the shirt.
Yeah, I was wearing the SQL Trail shirt recently. It's very soft, and I thought it was a bold move to give everyone V-necks. Just flip the script and give everyone female shirts. But I don't mind showing a little skin, so it worked out fine.
I was told
That's brilliant. That's very
right
nice.
is for both genders, right? So yes, we we did do something a little differently there. So anyway. Okay, so let's jump into it, right? So SQL Server and graph data. So we've touched on this a little bit before, but Mala, why don't you go ahead and give us a little introduction and talk to us about, right? So normally we think about SQL Server relational database. Maybe talk to us a little bit about graph, what it is, and why we might need it.
So I happened to get interested in this fairly accidentally about a couple of years ago at the summit while I was standing near the Microsoft booth and talking to someone, and somebody had I did math when I was in school. It's been a long time since I went to school, but I remember some of it. Particularly, everybody tends to remember the subjects and the topics that you were interested in. So I remember some of set theory and various graph theory and all of that I learned. And somebody there had a question on what is transitive closure and if SQL graph could handle it or not. I think this was 2017. I think it was quite a long time. That was the first version they came out with. So back then, and I knew what that was, and I happened to explain it. And somebody there, one of the Microsoft people, asked me, "Why don't you research this feature we have a little bit further, and you seem to know a bit about this." So that's how I started. I went down this path of trying to understand what the feature was about and how it was competing against other graph stuff that we have out in the market and such. And I did quite a bit of work, even considered writing up a book on it, which didn't quite pan out because the feature didn't evolve in the way I thought it would. And like it is with all Microsoft features, you don't know if it's out there just for experimental reasons or if it's really going to evolve into something that everybody can use. So graph theory, it's been around for like a really, really long time. It goes back to 18th century. And I'm sure every presenter who's presented on this has talked about the Königsberg Bridge problem and, Euler, the brilliant mathematician who solved that and came up with the various terminologies that we use to describe graph data as of now. That is nodes and vertices and how they're connected and the rules around that and all of that. So basically that, a town that had 7 bridges and the mayor had a contest where he wanted somebody to come up with a path where you could walk from, across each bridge just once and then come back to where you started without going over any path more than once. And this is kind of the problem that, at least I was given a number of these problems as a kid, like given a simple math puzzle where you don't take your pencil off the paper, you go from point A to point B, going across each line just once, that kind of a thing. So he solved this problem by, coming up with some conditions where you could do that. Obviously, you couldn't do that with 7 bridges. So you had, one of the bridges are gone and you had basically two with odd number of connections out of them, and that's how he made it work. So he called each landmass a node and the connection to it edges, and that's how this terminology evolved. So this has been around it's a mathematical theory, so there's a lot more to it. It's way simplistic to say that's how he solved the problem, but his theory is pretty involved in detail. But that's how it evolved, and after that, we didn't have graph.
Do you remember? You forgive me, Mala, for interrupting you.
Sure.
So what town was this? Do you remember the town?
Königsberg, in what was Prussia in olden days and what is part of Russia as of now.
Interesting. Okay, so I did
It is
not realize.
Konigberg. And I'm saying it like, a typical English-speaking person would say. I don't know how it is said in their native. I'm pretty sure it's not the same thing.
Sure.
But yeah.
Königsberg, by the way.
Sorry, Kevin?
Königsberg. That's how a person with an American accent would say it in German.
So ultimately it came from a contest, right? So node and edges, that's how I got those names, right? That's something else, because
Right.
sometimes you wonder how things get named, right? And
Right.
Admittedly, I hadn't thought too much about it, but I wasn't sure if Microsoft marketing had gotten its chops on that, right? And
No, it's not even the match clause, which is part of the implementation. Even that is not that's not from Microsoft. That's from stolen from graph query languages. So
okay, so we went from bridges, right, and being able to cross a bridge only once and get through the whole town, to, well, gosh, now, and maybe this is a more, I'm lacking slightly, but I tend to think of graph databases helping me with a lot of the hierarchy stuff, right?
Right, yeah, you're correct there. So Let me continue with that. Is that
Go
graph
for it.
theory is very, very old. This is an 18th century story, but that theory has been around a long time, and it's been shredded to pieces by mathematicians all over the world. So graph databases, they are fairly recent. They didn't evolve until the 2000s, and before that there was some kind of a history to it. But the actual graph database, which is a prominent vendor, Neo4j, that is their claim to it, is fairly recent after the NoSQL movement started. So before that, they used to have areas like the IBM networking model, where you didn't have a query language or anything for it. You had to know the internals of the hardware to traverse that thing. But that was the original implementation. And after that, we had a lot of code written in SQL to traverse hierarchies and do graph-like queries. And part of, quite a lot of graph processing still happens with SQL, because SQL was there way before these graph databases even came into the scene. So graph databases are fairly recent, and they started out, after NoSQL started in 2000, and Neo4j says that theirs is the first on the scene. So that's how it evolved. And with graph databases right now, processing of highly interconnected data, which is what graph data is about, and basically the data that qualifies to be called graph data is something that has way more connections or way more relationship than it has entities. So if you have a lot of relationships in comparison to entities, and if your interest is in querying on relationships, not the entities themselves, then you're probably a candidate for a graph data. And there is a lot of hype around it. When I studied this, I understood like quite a significant amount of marketing that goes on with this is hype. So you have to be careful and use your discretion a lot to see if this is actually something. It's not going to replace relational, to my mind. It's not that kind of a thing. It is really special cases where you have a lot of relationships and you need to query on the relationships to make informed decisions in some cases. Hierarchies, as you said, hierarchies are definitely a form of graphs.
Sure. So in your experience, or are companies having to, so we have data all over, we have copies of data all over the place, right? We've got our relational systems, we copy over to data warehouses, and then we copy it into reports and Excel, and it moves, and it's everywhere. So are we seeing the data, or are there instances in which you might need to keep that some data in relational, but then also make it available in graph? Or is SQL Server trying to thread the needle and be like, no, just keep it in one format, and then we'll do both things for you, right?
The real graph databases, they are object-oriented, or at least they are based on object-oriented theory. The SQL implementation is like we call tables and stored procedures objects. It's not really objects. You call it that. It is, it's a wrapper on the existing relational model. And the way the graph tables are in SQL Server, it is basically an NVARCHAR key with a JSON string that defines, connections between table A, node table A to node table B, and says, you can label it whatever you like. So it can be useful. It is very simple queries that you can write based on the old ANSI style of writing queries, table A, comma, table B, and then use a match clause and say how entities in one node related to entities in another. So really simple way of doing things. And it certainly has potential, but it is really not, it's quite a far cry from what real graph databases do. And real graph databases have a use case when your querying needs are very high, like, social media is a great example of that, when you need to query things on relationships between things. And, in some cases, you can have things like fraud detection, where you want to detect patterns of behavior between, different cases. And there's a number of use cases for that. And data center modeling is also another thing, how different entities are connected within the data center. That's a fascinating use case, one that I want to explore a little bit more in detail and see if SQL Graph will help a little bit with that. But basically, the thing with SQL Graph is that you can write all, and this is where I came to a bit of a roadblock when it came to writing a book with it. To me, a new feature is something worthy if it can do something that anything before it cannot do in highly improved, significant ways. And you can write almost all the queries that you can write with the graph thing with, other ways of doing it in SQL. We used to do it there are 3 different ways we used to do it in SQL. Basically, one is the adjacency list model, which is basically the subordinate boss thing you see in almost every organization, where, you have a record for you as an employee and your boss's ID is part of that as part of the hierarchy. If you go a little bit further and normalize it and clean it up a little bit, then that will be a separate table. But most people don't even go that far. You have your boss's ID as part of your ID, and you try to, write a recursive CTE to make up the org chart and things like that. That's one way you do it. That's the adjacency list model. And by the way, that's what Graph Database used the cover instead of the B tree that we use. So it makes querying relationships really simple. Like, this is related to that, is related to that, as opposed to how we do it in B-tree. And the other one is what is called the path enumeration model, or that's where the hierarchy ID and things like that with XPath and XML, where you store the whole path. And the third one, a little bit more complicated one, and I have worked at one place that had it, is the nested sets one, where you store, your neighbor to the left and your neighbor to the right, like 2 IDs on the same record. And then you query based on that. It's like, it's horrific to query, but it's one it's one way to do it. So you had at least 3 different ways of doing it before SQL Graph came on the scene. And a lot of places, they've evolved these things considerably well. So there is definitely a place for SQL Graph, but I'm not sure if it's worth the effort to deconstruct any of that and put this in place if you have it. But if you don't have anything and you're starting out brand new and your data set is not all that big and you want to play with it, it's an option. That's for sure.
There you go. Okay. So maybe it hasn't gotten to the point where you feel like you would reconstruct your data around it. But again, right, new development might be worth checking out.
So I was reserving this for a little bit later, but so there are some serious disadvantages or differences between SQL Graph and a regular, other full-fledged graph database thing like Neo4j, for example. One thing, it's not an object-oriented database. So part of the problem that a graph database tries to solve is polymorphic data or patterns that you have, and that is not very good. SQL Graph cannot possibly do that unless you want to, really write very involved queries and make each thing you're trying to query into an attribute in a table and, slap a relational model on it. It's really seriously hard to do. So it doesn't add up to an object-oriented database. And the second thing is what we call a reachability matrix. A reachability matrix is typically when you go to an airline site, and you want to say, I want to go from Raleigh to Pittsburgh and I want to query all the flights that are there. It's going to give you everything that's possible, unless you want to filter by something. Every way of getting from Raleigh to Pittsburgh is going to show up. So all connections between node A and node B in one shot you get. That's what is called a reachability matrix. And you can't get that out of the box unless you want to write really involved queries. You can write queries, CTEs and get to it. You can, but it's not intuitive, and graph databases make that very intuitive. So that is another thing. And the third thing is that really there's no visualization. The visualization around that, and some of the graph database visuals are very, very good, and you have Power BI plugins for that to some extent, but the Power BI plugins, even for hierarchies, are not that good. And the bigger the data gets, the more skewed it gets. So a lot of things. If you have a serious use case for graph data, it would be better to look into one of the full-fledged graph databases that support all these things. Do you agree, Kevin?
The nice part of me says yes. the less nice part of me says, honestly, I think graph is overrated.
Go on, please. I want to listen.
Well, so graph concepts. I wanted to get maximum viewer rage because hate clicks also count when it comes to stats. So you can make that the header. Graph databases are unnecessary. Get all the Neo4j people to watch the show.
Yeah.
He's totally evil.
So, in fairness, there are a lot of algorithms that have come out of graph theory that are very useful. A lot of the work that Dijkstra has done, as just one brief example, very useful. But you can store anything that you could put in graph in relational without having to use the two concepts of nodes and edges. You just have relations. And Mala did lay out the three different ways of storing hierarchical data in SQL. And there are advantages and disadvantages to each. Like adjacency sets are easiest to understand. They're easiest to query against. They're worst for performance. There actually are benefits to nested sets around basically they're a real pain to query, but keeping them up to date and moving people around in the nested set is actually really easy to maintain. It does require a different way of thinking about it, but I don't see much in the way of major benefits when using graph databases for most cases. Like if I'm going to get to that point, then I start asking, well, why not just use something completely different as well? If we're talking about understanding relations between entities, relational databases do that too.
Yeah, like that problem's already been solved, right?
Yeah. And all right, things like shortest path. Shortest path is harder to calculate in SQL. If you're talking about a recursive algorithm, it's harder to do in SQL. And that's where you can get to a place where something else would be better. And yeah, graph can
to be fair to Shreya and the fantastic team at Microsoft, their shortest path algorithm works really, really well. It does not work for a humongous amount of data, maybe, but for a decent sized data that I tried with, it works well. And in some cases, I was a little disappointed that it didn't give me all the shortest path. They only pick one if you have multiple, which to me, I didn't get the result that I wanted. I wish they showed me everything if there were multiple options there, but it's still not too bad and it works fine.
Right.
Yeah.
And so for a lot of cases, unless your company is heavily invested in things that graph is significantly better at, I just don't think it's worth it to say, well, I'm going to partition out this data and move it all over to another data storage technology, querying it with another language, using a different set of concepts to perform this one thing, and then a lot of other things over here. I think you'd have to get a bigger benefit, and I just don't see where graph in most circumstances gives you that benefit. Yeah, I can build out an org chart more easily, but how often do we do that in a place where the adjacency set model won't work? And B, how well does that scale? Because I know we can make relational databases scale extremely well. I know that if you get beyond that, all right, well, fine. Let me go put it into a Hadoop cluster or Spark cluster. It seems like graph is a very interesting branch of mathematics, a very interesting set of algorithms that I would probably apply using other technologies rather than having a standalone database, unless my company's main source of revenue or main internal intellectual property was extremely heavily tied into graph.
So neural networks are also a form of graph, right, Kevin? Do you agree with that?
You can you can visualize a neural network as a graph. It's a series of steps and operations, but I wouldn't directly call it a graph. I would say that's closer to an analogy than actual structure of information in there.
Yeah, fair enough.
Unless you're saying, like a decision tree is a graph. But yes, technically a decision tree is a directed acyclic graph. All right. But that doesn't mean it's a graph database.
No.
Sure.
So this buyer behavior thing that I was looking into some of the examples that the graph vendors typically sell, and one of them is around buyer behavior, that it helps a lot with understanding buyer behavior. Like if you buy product A, you may like product B, C, and all. To my mind, I felt like, probably machine learning might help a little bit more there than just a graph database query. Is that correct? Or at least using a machine learning model on top of a graph database.
Yeah, I mean, I would completely agree with that idea. That's my thought, where if you are in the business of goods marketing, then maybe having a graph database implementation could be more efficient. But for most of us, we're just going to say, take all those purchases, pull them up into R or Python, and run algorithms off of that. So yeah, we're using graph concepts. We're using market basket analysis, associative rules, and that kind of stuff is what we've learned from graph. Again, you don't need a graph database to do that work. And I'm not sure that a graph database is helpful unless that is your main job.
Yeah.
Interesting.
Yeah, that is interesting. So to Mala's point earlier, she talked about, well, sometimes they introduce features and you don't really know what's going to become of them. I didn't hear any rumblings about graph in 2019.
So I suggested that having it may, be hackathon compatible, where you can throw the table into memory, and, because that's how, some of the graph databases work is, the whole structure is in memory and works extremely fast compared to running a query. That might actually increase the competitive advantage at least. And I hope, if the feature evolves, that they'd consider doing that. But, yeah, that's a problem when it comes to performance too right now. They did make some changes. They made referential integrity to the, edge tables there. So you cannot have orphan records. So clearly mine and Eugene's MVP nominations don't belong in the edge table. We are not orphan records.
So that's what happened. You dropping some bombs here, Mala?
Well, no, it's funny because I'm somewhere in the database, because there was a Microsoft person who reached out to me about some potential work for a client a year or two ago. And he's like, well, you're an MVP. And I'm like, no, I'm not. And he's like, oh. So I must be in some database somewhere.
Yeah.
No, when I heard you say that on the podcast, I was like, okay, so I have company. I'm not the only person like this.
Yeah.
Yeah, they'll make anyone an MVP these days.
Well, hey, one of these things is not like the other. One of these things just isn't the same. No, wrong way. There you go.
You had it right the first time on my screen.
Oh, yeah. Oh, yeah. Okay. So interesting. So I think that's an interesting idea, right? So, as we get into graph, and particularly as a database administrator, you're like, oh, well, should I start implementing graph, or should I start trying to think about storing my data there? So it sounds like what we're saying is, probably not. However, you will apply graph principles. You would talk about what you want.
No, it's certainly something good for everybody to understand, and how to improve and query. Yeah, that's where it helped me. I don't regret going down the learning path with any of this. Whether or not that particular feature evolves is not the point. You understand the data structures better. You understand what are the different options that are out there to query them and make the best out of what you can get. So I think, learning about it is definitely important. It does have a place. It does have a significant place everywhere. Hey, even your ER diagram in a way is a graph-like structure. So if you learn to query, I wrote one article for that for SQL Server Central and working on the second part. It's been a while, but you can actually write pretty good queries to query on foreign keys and how to get, connections from one table to another and such. It's pretty cool to play with. Because
Yep.
that's a form of graph too. Yeah.
Yeah, oh, completely agree. Understanding graph concepts, despite all of my reticence about graph databases, graph concepts are incredibly useful.
Mm-hmm.
I just would tend to use other languages and other ways to store the data. But
Mm-hmm.
those concepts, really important to know. They are a core part of computer science.
Yes. So the one of the advantages with SQL Graph also is that if you know T-SQL and you know the underlying table structure, you can write some queries off of it. Whereas with other graph databases, you have to learn, there is a computing engine and there is a query language you have to learn. And a lot of these computing engines work off multiple query languages too. So your learning curve may be a bit steeper in that regard, if anybody wants to learn a full-fledged graph database. It's not just about any one thing. You have to learn multiple things about it. But it's pretty interesting, and Neo4j is pretty well documented. To give them credit, their documentation is very, very good. Yeah.
Very, very good.
Yeah.
Good deal. Yeah, well, we're happy to give shout outs where shout outs are due, right? So
Yeah.
now Eugenia may have missed a moment, but did you have something you wanted to jump in there with?
I've lost track, unfortunately.
Okay.
So no, I think we're good.
Well, awesome. Well, so I guess maybe Mala, should we do SQL Family?
Yes.
Nice. Okay, so how did you first get started with SQL Server?
So I started in 1997, I think. I was employed as a Visual Basic programmer with a firm on Wall Street, and my boss was the DBA, SQL Server DBA on SQL Server 6. My first project was migrating from SQL Server 6 to 6.5. And and he taught me the essentials of database, and we used a tool called DB Artisan. I don't know if that's still around, because Management Studio back then was so limited. That tool gave us more options to work with it. That's how I learned. And my boss, one Friday evening, he went out for a happy hour, and he came back and he dropped a mission critical database. And there was no warning or anything back then on SQL Server 6. I think if you right click and dropped it, it just went if there was nobody connected to it. So it was gone.
Oh, wow.
So I got a call at about, close to midnight saying that, asking me to come in, and there's a limo on the way to pick me up because it was New York and we didn't have cars then, we used public transport. So they sent me a car to fetch me, and I went in and got my first DBA job.
If you can get this data back, the job is yours. Man, no pressure.
So I worked with the sysadmins, and we managed to retrieve the NBA file from the disk and put it back. But that's how I got my job.
Wow, man. That's pretty intense, and the car to boot, I think that's probably the most unique story I think I've ever heard.
That's been it's more than 25 years now. Yeah.
So now what advice would you give to someone who wanted to pursue a career similar to yours?
So I think it's totally worth it. The one advice I would give anyone, data career in today's world can be extremely rewarding, and it's, it pays well. It's a good use of your time and energy. I would always warn anyone, this is something I never knew in my early years, is to find a work-life balance and take good care of yourself, and not let your love of work take you away from taking care of your body, your health, or your family, or anything personal, because it doesn't work like that. Your body does not care how much you love what you do. It doesn't. It really doesn't. It has needs of its own. So take care of it, eat well, exercise, take time away from work. that's important.
What's one thing that can instantly make your day better?
I was thinking about this question from yesterday, and there was a number of fun answers I could have given, but I think this needs to be said. Today, in today's world, I would say any day that I get up and I hear that nobody I know in my friend or family circle is sick or dead makes a good day.
Wow. Yeah.
That's not probably not what you were expecting. It's a strong statement, but sadly, it happens to be true.
Sure. I think, lots of attention now is being, paid to, in COVID terms, and there's loss of life, which is always sad.
Right.
And I think because of the concentrated focus on it, it can help us step back and remember that life is precious. And we've got to take advantage. Almost going back to your last point, right? Is that take care of yourself and enjoy it while you can.
Right.
You have $10,000. What computer or technology would you buy?
I would like. Kevin said something.
The check is in the mail.
I would like one of those big monitors like my friend Anders has, the TV kind of monitors. I don't do well with multiple small monitors. I just work with one laptop. For some reason, I find them too distracting. But I like what he has where you can, the whole thing is tiled on a big, huge screen. So that would be my choice.
There you go.
And if I have any money left over, I would like an Adobe, the full subscription, to play with all my old photographs and various artwork and such.
There you go. Very nice. So that TV like be one of the ones that curve. Have you seen those curved ones?
Right. That's what he has.
Yeah.
If you ever get a chance to see Anders's, computer room, I would suggest asking to see it. It's pretty fancy. The guy goes all the way out. Yeah.
We'll have to get him to snap a photo for us. What famous person in history would you want to spend the day with?
My choice would probably be Walt Disney, because somebody who had very humble origins and who worked extremely hard and was super creative and actually made something really grand happen. I would like to sit down with the guy and ask him about how he even visualized something so grand coming out of his.
Sure. So now I'm curious to follow up there. At what point in his career would it be towards the end of his life, or would you want to meet with him, maybe towards the Steamboat Willie days?
Steamboat Willie days.
Steamboat Willie days. Okay.
Yes.
Yeah.
Because that's when, you can, I am really inspired by people who have something great ahead of them, but don't quite know it yet, because that was me.
There you go. So good things are ahead.
Yeah.
Mala, our last question for you today. You're getting a big old bowl of ice cream because you've taken care of your body all week. We're going into the weekend. You're like, I'm going to eat some ice cream. What's your favorite ice cream topping?
Or I don't know if it's actually a bummer. I'm allergic to some kind of fats, and I am allergic to most ice cream.
Oh.
So it has helped me because I don't gain weight like other people do, but I really can't eat ice cream. I can eat gelato. And, I love all kinds of gelato, actually, without any toppings. The original fruit ones that you get in Italy, those are amazing. And if I wanted to add a topping, it would probably be crushed walnuts. Those are my favorite.
There you go. Awesome. Well, Mala, I'm glad we could get you on the show. Thank you for coming and sharing some thoughts with us. It's been great.
Thank you.
And as always, compañeros, you can reach out to us. And I guess, Mala, if folks wanted to reach out to you, say hello, thank you, whatever, how could they get in touch with you?
I am on Twitter. I go by SQLMAL. That would be the best way to reach me.
Mr. Eugene?
Yeah, I'm on Twitter at SQLGene, and I blog at SQLGene.com.
Mr. Kevin?
My social media details are actually in a Neo4j database, which is why I'm trying to warn everybody away from using it.
I love that.
It's actually connected to Eugene's, oddly enough.
Yeah. Okay, compañeros, you can reach me at Carlos L. Chacon on LinkedIn. So we are, let's see, I'm not sure that we'll be live. We are actually migrating our website. We're updating it. There's some debate as to whether the leave a voice message feature is going to stay. And so because we have Mala here, right? She's the only one who's used it. Anyway, leave us a note, talk to us, and
just send an anonymous survey to all the people who've used the product.
yeah, there you go. Let us know if that's something you want us to keep around, because right now I think it's on the chopping block. So I guess that you might hold the distinction forever, Mala. That might be a distinction. We'll have to make you a trophy or something about that. Anyway, okay.
I want to hold the distinction of ordering the first female shirt too.
Okay,
Make that possible.
there we go. We'll make that possible.
All right.
Okay, awesome. Thanks again, compañeros, and we'll see you on the SQL Trail.
Bye.
SQL Data Partners.